Okay, this is 13.6. It's the last section in the chapter. So we'll be doing this, and then we'll be reviewing and taking a quiz on the 5th of December. So make sure that you're getting these assignments finished up, caught up, so that you don't have to worry about anything. We're going to start today, actually, I need to add a new slide in here. We're going to start by talking about what's called the law of cosines. There are times when we try to do the law of sines, but we're missing too much information, or we're just missing the wrong information, so we can't get anywhere. For instance, with the law of sines, you have to have an angle and its opposite side before you can do anything. And so sometimes we end up with things where we don't have enough information. So because of that, we'll have to find other ways around. For instance, the law of cosine says that if I want to know a, I know that a squared is equal to b squared plus c squared. Hey, that looks like Pythagorean's theorem, but there's a little bit of modification to it. We also have to subtract a little bit. So we're going to subtract 2 times bc times the cosine of capital A. This chunk right here deals with the missing information because it's not a right triangle. If you'll notice that B and C are the letters that are used twice on this side, and then capital A matches with little a. So it makes sense that B squared would be a squared plus c squared minus 2ac cosine of capital B. These formulas I would write down on a note card or have access to, but no, I should probably write that in the other order. I haven't done anything wrong, it's just, a squared, then b squared, minus 2ab cosine of c. Any one of these three is the law of cosines. We just have to know which ones we're looking for. The fact is that if I take and put b here, obviously I'm just going to trade a and b places, all the way through, including the angle there. So either of these, if you can remember one of the three, you should be able to modify them to fit the others. But I would definitely have them written down somewhere I have access to. So when we come in here and we need to solve the triangle, we're missing angle C, we're missing angle B, and we're missing side A, which means I don't actually have any angle with its opposite side. So the law of sines would not work. You could try all day and it will not work because you're missing too much information. But using the law of cosines, I should be able to find stuff. For instance, because I know I have the capital A, I might go looking for little a. So a squared equals b squared, we'll just write it down, b squared plus c squared minus 2bc cosine of a. So if I plug everything in, b is 23, I'll square it, plus 26 squared minus 2 times 23 times 26 times the cosine of 114 degrees. All of this equals a squared. So a squared equals, and again, we're just going to throw this into the calculator. 23 squared plus 26 squared minus 2 times 23 times 26 times the cosine of 114 degrees. Make sure you're in degree mode. A squared equals 1691.5. And to get a, I'll take the square root. And a equals 41.1. And that makes sense because it's the biggest angle. Now to find b and c, obviously I only need to find one of them. The other one I'll just subtract from 180. But to find b, for instance, I'm going to say that b squared equals a squared plus c squared minus 2ac times the cosine of b. And this is what I'm looking for. So to do that, I'm going to plug in the values and slowly solve for b. All right? Well, b squared, we know, is 23 squared equals a squared, which is 41, we'll just go with 41 squared, plus 26 squared minus 2 times 41 times 26 times the cosine of b, which I don't know. I'm going to plug a lot of this in. I'm going to try to simplify. 23 squared is 529. That's equal to 41 squared plus 26 squared equals 2357 minus 2 times 41 times 26 equals 2132 cosine of b. Let me make this very clear. You cannot, under any circumstances, subtract here. We are not allowed to do that. We first have to subtract, then divide, then deal with the cosine. Do not ever combine these. If you're missing the variable if the variable you're missing is an angle, you have to move things over one piece at a time. So minus 2357. So then I have 529 minus 2357. It's negative 1828 equals negative 2132 cosine of b. Now I can divide by negative 2132. Divide by negative 2132. And the cosine of b equals, divided by negative 2132 equals 0.857. To get b alone, I'll use the cosine inverse of that. And I get that the angle B is about 31 degrees. So I'm going to slide up here, put B equals 31 degrees. And then I should be able to count 114 plus 31 and take that away from 180 to get a 35 degree angle. And now I have all pieces of information. Is this a little bit more complicated? When it comes to finding the angles, it is a little bit tougher. To finding a side, that's pretty easy. Not to mention that I could throw all of this in my calculator at the same time. No need to do it all by hand, one piece at a time. But when we're doing those angles, it is a little bit tougher. Number 14, they give us just side lengths, and that means we do have to go through the process twice of finding the capitals. But you know, each individual step, not complicated, just doing it all together can take some time. A squared equals b squared plus c squared minus 2bc cosine of a. Let's go ahead and plug away. Let's find that capital A. You might right away try to subtract b squared and c squared. You know, have a squared minus b squared minus c squared equals negative 2bc cosine of a. That's going to save us a little bit of time when we put stuff in the calculator. This is 38 squared minus 31 squared minus 35 squared. Now here, because I'm subtracting those, I'm not going to use parentheses around the negatives. Be careful there. That is one caution. You should end up with a negative number. 2 times 31 times 35 cosine of a. Well, 38 squared minus 31 squared minus 35 squared ends up being negative 742. That's equal to negative 2 times 31 times 35. It's 2170. Oh, sorry guys. A little bit of an issue there with doing too many videos at once. Uh-oh. Oh, I'm in trouble now. Okay, let's see if I can get that cleaned up. Wow, that was a disaster. Okay, let's see if we can get this to work. Negative 742 equals negative 2170 cosine of A. Divide by negative 2170. Divide by negative 2170. Cosine of A equals negative 742 divided by negative 2170 equals 0.34 for 2, obviously take the cosine inverse, and A equals 70 degrees. So capital A equals 70 degrees. I still need to find capital B and capital C to have my answer. Well, here's the deal though. I could go through this mess again, or because I now know an angle and its opposite side, I should be able to use the law of sines. So the sine of 70 degrees over A is 38 should equal the sine of, say, B over, what's B? B is 31. This is a lot easier to finish than the original. Sine of B equals, and if I put all that in the calculator, 31 times the sine of 70 divided by 38, I get 0.767, and I'll take the sine inverse of both, and B will come out as 50 degrees. And now that I have 50 degrees and 70 degrees, that's 120. That tells me this should be 60 degrees. And I am done. Remember, that was 35. If that messed you up. Sorry about the little slice through everything. I was trying to do 2 videos at once, so my bad. Next problem that we want to look at together is number 21. There's a special guy named Heron. He came up with a nice formula for us that works off of this idea that all we know is the side lengths. Can we find the area of this? Well, I could go in and try to create a height. That height would be a little time consuming to try and calculate. And that would be that, that 1/2 AB sine of C type idea. The problem is I don't know any of the angles. I'd have to go and find an angle, go through that whole mess. Well, Heron's formula, for area is that area equals the square root of S times S minus A times S minus B times S minus C. You might say, well, what's this S? I get there's A, B, and C, and we can literally go in here and I don't know if the book had a specific A, B, and C. It did. A was down here, B, C. So I could go in and throw the little a, little b, little c in. But how do I know what S is? Well, S is the semi-perimeter. Sorry about the sloppy handwriting. Which means that S is 1/2 of little a plus little b plus little c. Go all the way around, cut it in half. Well, 21 plus 11 plus 19 equals 51. So the perimeter equals 51. So little s is going to be half of that. 51 divided by 2 is 25.5. Okay, so in my calculator, I'm going to say A equals the square root of 25.5 times 25.5 minus little a is 19, because it's opposite from it, times 25.5 minus little b would be 21 times 25.5 minus 11. And as long as I put all that into the calculator just the way it is, and by the way, it would not matter if I changed the order of these, because in the end, A, B, and C, they're interchangeable for this formula. So that's nice as well. But I'm going to take that, 25.5 times 25.5 minus 19 times 25.5 minus 21 times 25.5 minus 11, and multiply all that together, and I'll take the square root of it, and I will get that the area of this triangle is approximately 104 units squared. They don't tell me feet or inches, so I'm just going to say units squared. Well, I'm going to use the same thing on 32, that the area equals the square root of s times s minus a times s minus b times s minus c. And s, half of the perimeter, so 38 plus 25 plus 61 is 124 divided by 2 equals s equals 62. And so I'm going to have the square root of 62 times 62 minus 38 times 62 minus 25 times 62 minus 61. And what I'm actually going to do in here is I'm going to pull up my calculator and show you how I type all of this in at the same time. So clear this out. We're going to hit second root. And see, I have a starting parenthesis. Everything I type now is inside this parenthesis. So I'm going to start a new parenthesis, 25, new parenthesis, or sorry, wow, I'm still thinking of the last problem. 62, my bad, times 62 minus 38, close parenthesis, open parenthesis, 62 minus 25, close parenthesis, open parenthesis, 62 minus 61, close parenthesis. Then I'm going to close the parenthesis for the whole root. See, there's a double parenthesis to start, a double parenthesis to end. That's a good thing. If I hit enter here, I get 234.6. So we'll say 234.6 units squared. That is the area of a triangle that has those specific measurements. If it does, that's it. And so the last part of the assignment, if I recall correctly, to get through number 40, there's a couple of problems where it asks you to solve using law of sines, law of cosines, or the Pythagorean theorem. Obviously, if you have Pythagorean theorem, that's really nice. Anything you can to solve it will work. Now, Pythagorean's theorem only works if you find a 90-degree angle. So number 39 has one. I don't know if there's another, but that one does, and you can work off of that to try and figure out the rest. But they're just law of sines, law of cosines, or Pythagorean's theorem. You could use the law of sines on any of these, or law of cosines on any of them. You just have to figure out which ones work. There are a couple that you can't use the law of sines on. You have to start with the law of cosines and then finish. If that's confusing to you at all, just work with me in class and we'll get it figured out. Thanks.